All right, so lesson 45, what's that all about? Range, median, mode, and mean. Who can tell me what the range is? I have a series of numbers. I'm going to write down a series of numbers here. I tell you what, everybody give me a number. Give me a number, Alexa.
11.
11. Alexa says 11. Ada?
71.
71. Wow. All right.
40.
40. Okay.
60.
60. Okay.
25.
25. Okay. Nice.
5.
5. All right. I like it.
21.
21. Okay. Cohen?
7.
7. Okay. And then finally, Liliana? 2.
82.
82. Okay. All right. 82. And I'm going to do this. I'm going to put another 60 right here. All right. So we've got a list of numbers like this. Who can tell me what the range is?
You find the biggest and least number and you subtract them.
That's right. So the range is going to be your biggest number, which is 82, minus the smallest number, which is 5. So for this one here, our range would be 77, right? Now, in order to do this, when you're given a list of numbers, the first step is going to be to do what I just did. Take those numbers and put them in numerical order, right, from least to the greatest. So that's how you find the range. What about the median?
Don't you add them all together and then how many numbers are there, you divide it by that?
Nope, that's the mean.
Okay.
So the median is something different. Who knows the median? Take a stab at it. You're about to say something, I thought, Ada. No?
It's written on my paper, but just in case I'm not going to answer it.
You know,
Is
Alexa?
it like the middle number?
It's the middle number. So when you put them in order, you count the numbers of numbers that you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10. If it's an odd number, you're going to have 1 right in the center. So had I had 11, I would have counted to the 6th number. 1, 2, 3, 4, 5, 6. 40 would have been my middle number. But since I have 10, I'm going to have 2 middle numbers. So the 5th and the 6th number are going to be my middle number. So in this case here, this number and this number will be my middle number. So what do I do when I've got 2 numbers that are in the middle?
Subtract.
No?
Or add.
I do the average thing you were just talking about. I add the 2 together and divide it by 2, right? So I'm going to go 25 plus 40 divided by 2. And so that's going to be 65 divided by 2, which is 32.5. So that would be my median. So I had a lot of help on that one there. Let's see. I know Jonah, you said something too. Anybody else help me with that one? You were close, Ada. You were almost there. You were about to say something. Was that what you were going to say?
I was thinking about it and then I just
All right.
just in case.
All right. So now what about the mode? And someone that's not on the board. Can you tell me what the mode is in that group? Hannah?
It's like 2 of the same number that are in.
Yeah, it's the number that is most frequently occurs, right? And so it might be in this case it's 2. We have one number that shows up twice, right? There's only one that happens with. So for this one here, 60 would be our mode because those are the most common numbers. Now, if I had another, let's say I had another 82 out here, then I've got 2 of those as well. So my mode would be both. It would be both 60 and 82.
What if there was no mode? Would you just put no mode?
If they were like all one,
Yeah.
yeah, you would say either none or say they all are. I would accept either of those. But right, if they give you a list like this, there's going to be something that there's more of. And so if one of them was like if I had 2 60s but had 3 82s, then 82 becomes our mode, right? Because we've got more 82s than anything else.
Yeah.
All right, good. And then finally, the last one. So let me write Hannah down. Finally, the last one is what. Was it you that said that, Will? You add them all together. So the mean is what we also refer to as the average, right? That's how most of us think of that word. Think of this term here. And with the mean, we just add them all together. So I'm gonna erase those extra 82s that I put in there, change that back to 60. And so to find the mean, you say 5 plus 7 plus 11 plus 21 plus 25 plus 40 plus 60 plus 60 plus 71 plus 82, and then however many we have, we count it up and we have 10 numbers. You take all of that and you divide it by 10. Anybody want to try to punch that in? See, how about a couple of you punch that in and let's make sure that we get the same answer. See Alexa working on it. Somebody else want to try it?
$372.
374?
372.
372. Okay,
Oh,
but you got to divide by 10. Yeah, it's like that can't be right because it'll always be a number that's somewhere in this range here. So 37.2. Did anybody else get that? Did anybody get something different? What'd you get, Liliana? Did you do it?
I got 32.1, but I'm probably wrong.
32.1. Let's see what somebody else gets. Is anybody else doing it? Ada's still working on it.
I got 382.
3 what?
382.
And then when you divide it by 10, you get 38.2. So, we've got 3 different answers here. All right, I'm gonna check it real quick too.
I actually put a 1 instead of 11.
Oh, okay. So, let's see. 5 plus 7 plus 11 plus 21 plus 25. I got 38.2. That's what you got, wasn't it, Ada?
Yes, sir.
All right. Cool. All right. So does that make sense to everybody? Any questions about that? That's all this chapter is about. So that's pretty straightforward, right? All right. Well, let's move on to lesson 47. And wait a minute. I'm sorry, 46. We're just on 45. So. It's simple, and I thought it would probably go pretty quickly. Let's talk about conjunctions. So we've had problems like this, and you guys have, I think you had it on the last test. So we might graph something that looks like this, or maybe we'll graph something that looks like this, right? So if I have a number line like this, and I ask you to graph x is greater than 5, how would I graph that? Yep, Ada?
Are we supposed to do these over the break?
No. Did you do them over the break? Okay. Did I actually assign homework over the break?
No.
Okay, yeah. I had at least one person email me and I say, yep, there's nothing due. But yeah, I didn't put anything on ThinkWave, so because I haven't lectured on this yet. But you're ahead of the game, right? So how do I graph x is greater than 5?
You do wait, yeah. So the arrow pointing that way.
An arrow pointing this way, okay? What am I doing right here at 5?
An empty circle.
An empty circle, right? So it has to be an open circle. Some of you missed that. And then I'm going to highlight everything on this end of my number line, right? Why is it an open circle and not a closed one? Yep.
Because it's not equal to.
Yeah, it's not greater than or equal to, right? There's no line under here. You only put the closed circle when there's a line, like there is on this one right here. And so for this one, x has to be less than 8. So I'm going to again put 8 in the middle, a 9 on this side, a 7 here. And we're going to close the circle in because it's less than or equal to. And since x is less than, we're going to go to the left on our number line. So this would be the graph of x is less than or equal to 8. Okay? So we've done that previously. Hopefully that makes sense to everybody. Some of you did miss that on the exam. So does everybody see why that would be so? Because this is saying x can be any value that's bigger than 5. That's what that says, right? So we're saying not 5, but anything that's bigger than 5 is everything over here. And here x can be any value that's less than or equal to 8. And so that's why we close in the circle and we say it's everything this way. It's less than 8, right? Now we're gonna kind of put these things together, and we're gonna have something that looks like this. that x is we're going to say 5 right here. And we're going to say x is greater than 5. Right, I put the x on this side, so it opens up to the x. So x is bigger than the 5 is. But then x is less than or equal to 8. So now we have statements like that. We call them conjunctions, where I'm putting two inequalities together. And so how would I graph that? Well, I've got on my number line, I'm going to have at least 5 through 8. So I always like to do at least one less and one bigger than the numbers I need. So I'm going to do this, and then put a 9 here. And x has to be bigger than 5. So I'm going to put, it's not greater than or equal to, it's just greater than. So I'm going to put an open circle on 5. And it has to be less than or equal to 8. So I'm going to put a closed circle on 8. And it's like the combination of these two things, right? The 8 one's going back in this direction because x less than or equal to 8 goes in that direction. But it can't be less than 5 because this part of it says x has to be greater than 5. So I'm going to fill in everything on my number line in between those 2 points. So that's how I put those two inequalities together and graph that conjunction. So does everybody see that? X is basically, the way this reads is x is in between 5 and 8, but includes 8. So that's why I graph it like that. Any questions about that? No? What about this? What if I have -2? What if I have that? I'm going to do what I did before. I'm always going to go one less than my lowest number, and one bigger than my highest number. Anybody want to tell me what I'm putting on there? Maybe someone not on the board? Cooper?
Would it be an open circle at the 3?
Yep.
And then a line to -2?
Okay, what am I putting it to? A closed or an open circle?
An open circle.
Open circle as well. Excellent. Right, both of these had to be open circles because we didn't have a line under any of these inequalities here. There was no equal to part of it. Excellent. Good job. All right, that's that lesson. Man, we're going at lightning speed today. The break really helped you guys. It's wonderful. All right, no questions? Let's move on to lesson 47. This is going to probably be the longest lesson to explain, but maybe not. Maybe you guys will surprise me. We're doing percents less than 100 and percents greater than 100. And really this isn't anything new. The only thing that's kind of new with this is we're going to be drawing a diagram. I don't think we've drawn the diagrams before. But we've done this idea of using percentages and fractions. The idea is basically the same, and decimals. So, what we said when we were doing fractions is we would have a statement that says 1/4 is, what fraction? It is, 1/4 is, how was it worded? This is how it was worded, I'm sorry. With the fractions, it was something like this. We would say 20 is 1/4 of what number? Okay, so we might have a statement, a question like that. And does anybody remember how we would write down these fractional questions?
20 is equal to 1/4 times what number? Times x.
Yeah, so we would do our fractional part, right? This would be our fraction, or it could be our decimal if we had a decimal. So we would have our fraction times our whole number. So this would be the whole, and that would equal the part. All right? And you can use whatever symbols you want for that. So you could say F, I think I would typically use F, and F times the whole equals the part, right? It's the same way with the decimal. The decimal of some whole is going to equal the part, right? So when we had 20 is 1/4 of what number, we would say is the what number here, the number we're trying to find, is it the whole or is it the part in this particular problem? Which one? It's the part. Is it? $20 is 1/4 of what number? It's actually the part. The 20 is the part, right? So the way that we would write this is we would say 1/4 of some number, some big number, our whole part is equal to, our whole number is equal to some part of that, which is the 20. Does that make sense? 1/4 of some bigger number is going to equal 20, is what this is asking. And the reason I know that is because the 20 is connected to the is part of it, and the is always is where the equal sign is. So whatever's connected with the is what's going to be the equal part. So the equals 20 goes over here, and the of goes with the whole. So the of goes with this, the is goes with that. And then the fraction and the decimal is always sort of the most obvious part that goes in the front. All right, so we would use a formula like that, and we would say W times 1/4 W equals 20, and then we would multiply both sides by 4 to get rid of our fraction, and our 4's would cancel out here, so we would say W equals 80. And we know that's true. Isn't it true that 20 is 1/4 of 80? Right? So we get an answer that makes sense based on the way the question is. We could restate that and say 20 is 1/4 of 80, and we're like, yeah, that's right, that makes sense. So that's the way that it worked with fractions. That's also the way that it worked with decimals. We're using the exact same formula when we start using percentages. It's just that for percentages, we're basically converting the percentages into decimals. And how do we convert a percentage into a decimal? Or a fraction? Do you guys know how we would do that? What is, if I say 80%, how do I
Crap, no, never mind, I can't.
How do I convert 80% into a decimal or a fraction?
Put it over 100.
Yeah, we divide this by 100, right? And so that's going to equal 8/10, which reduces down to 4/5, or we could say it equals 0.8, right? If we punch that in our calculator. So 80%, 0.8, and 4/5 are all the same thing. All right? So when we're dealing with percentages, if I say 20 is 20% of what number, right? If that's my question, I'm going to use the exact same formula, but I'm going to say percent divided by 100 times the whole equals the part. Okay? So I'm going to plug in, so that it won't be confusing to you, let me make this 30. 30 is 20% of what number? So I'm going to plug in the percent part right here. I'm going to say 20 divided by 100 times the number that we're trying to figure out, and the part is the 30. Now how do if I've got 20 over 100, if I've got a fraction right here, times this W, and I'm trying to figure out the W, how do I get the W all by itself?
You put it on the other side of the equal sign?
I want to get rid of this. How do I get rid of that fraction? How would I get rid of this fraction? I'm sorry, not fraction. How would I get rid of it? Let's say I had that. How would I get rid of that 2?
You move it to the other side of the equal sign.
But how do I move the 2 over here? How do I get rid of this so that the W is all by
I
itself?
don't know the name of it.
Divide?
I just divide, right? These are multiplied together, so to get rid of the 2, I just divide both sides by 2, right? Simple algebra. You guys, if you're still struggling with that, that's something that you need to like pull up Khan Academy and make sure you get down. All right. But that's what we do with just getting rid of a number that's multiplied times our variable. We just divide both sides by that. Okay. This is just a number multiplied by our variable, and so to get rid of it, we divide by it. We divide by 20 over 100. But we're dividing by a fraction. How do we do division by a fraction? We don't think of that as dividing. What do we think of that as?
You swap the numerator and the denominator.
Yeah. What's the mathematical term for that?
Reciprocal?
The reciprocal, right? So instead of dividing by a fraction, we multiply by the reciprocal of that fraction, right? So that's what we're actually doing. And the rules in algebra, the rules are that whatever I do to one side, if I'm multiplying one side by 100 over 20, I got to do that to the other side, right? So here, my 100 over 20, my 100s cancel out, my 20s cancel out, so I'm left with just my W here. And then when I multiply 30 times this, I'm going to get 3,000 divided by 20. And if I punch that into my calculator, I'm going to get 150. Is that right?
That's what I got.
Okay. How did I figure that out in my head? It's a big number. This is what I did. I said, oh, 20 goes into 10 5 times. 5 times 30 is 150. Right? So don't forget you can reduce your fractions a lot of times just very easily in your head. At the very least, when you've got two fractions with zeros at the end, you can cross the zeros out. Like that. For every zero that's on the top, you can cross out a zero on the bottom. All right, but it's the same exact concept. The only thing we have to remember, if you knew how to do these problems, the only thing we have to remember is that we have to take the percentage and put it over 100, all right, in order to do the problem. Now, what they also want us to do here is they want us to draw a diagram, all right? And with the diagram, what we do is we say, we draw a circle over here, which represents the 100% that we started with. So in this case, the thing that what we started with was 150. So of 150, that was 100%. Notice here we're trying to find the of what number. So that's the 150. And then when we take 20% of that, it looks like this. We have another circle. Here's what we end up with. We got 20% up top here. So 30 is 20%. And the nice thing about doing it this way is sometimes with these problems we need to see what's left over. Does everybody see that if 30 is 20%, then 120's got to be 80%? This is what we have. So this was before. When you take a percentage of something, that's what you have before, and this is what you have after. Why do I have 120 and 80% on the bottom part here? Because our problem only dealt with the fact that 30 was 20% of 150. Where did that come from? Anybody explain that? I'm going to just drink some coffee while you guys think about that. Where did I get those numbers, Cohen? Do you know?
I think it would be from, since you have on the after, you have it to where both of them equal up to 150, and they all end up going
Into 100. So it's like you divide it by something.
You're on the right track. It's not dividing, but the 120, do you guys see that this 120 is what we started with, the 150 minus the 30? that we ended up with, right? 150 minus 30 equals 120, right? And what was the 150? The 150 was 100% of something. And so this 80 right here comes from the fact that 100% minus the 20% that we have up top equals 80%. Okay? That's enough to at least get your name on the board. Come on. Do you guys see that now? Makes sense where those numbers came from? In this problem, it's not really that helpful, but there will be word problems that they eventually give us in the future that it's going to be important that you understand how to calculate the part that's left over there. Okay? The other portion of that. All right, let's do another one. And I think the more that you do these things, the easier they're going to be. So I just want to make sure that you get the fact that our basic formula is some percentage divided by 100 times the whole equals the part. All right? And the way that you think about the times is this is our of, and this is our is. Okay? So some percentage of a big number, or it could be, if this percentage is greater than 100, it could be a smaller number. We'll talk about that in a second. But some percentage of some number is another number. All right? That's our basic formula. So let's try another one. 20%, this is very similar to what we just did. But I'm going to take my time on these because I want to make sure everybody gets it. 20% of what number is 15? %20 of what number is 15? Tell me my initial formula that I'm going to write down. Nobody knows? This question here is written exactly like this statement's written.
20% and then
20%.
100 for the denominator.
Over 100, yep, good.
And then times x or what number?
What number? So we don't know what that is. What number? You can use WN is what they tend to use in the book to mean what number. All right.
15.
Equals 15. Good. Everybody see that? And so we're going to do just like we did last time. We're going to say, all right, I need to multiply both sides by the reciprocal of my fraction so that I can get rid of the fraction on this side to determine this variable right here. So multiply both sides by 100 over 20. That makes this stuff cancel out. So WN equals 15 times 100 over 20. Now again, I can think of that in my head. 100 will divide into 20 will divide into 100 5 times. So 5 times 15, that's what, 75? So our number is 75. Is that right? Yes. So 20% of 75 equals 15. And then they want you to draw a diagram. So let's see if we can draw our diagram. This is our whole, that's what we started with. So this is the before part, where we had 100%. So to start with, we're at 100% of something. And what is that 100%? What did we start with before we took a percentage? Our choices are the 75 or the 15. Which one's the starting number? Which one's the 100%?
75.
75, right? So of 75. And then we have a smaller percentage of that, which we said was the 15. 15 is 20%. All right, this is the after. All right. So on our bottom part here, we've also got an is, and so there's some number that goes right here and some percentage that goes right here.
Would it be 75 minus 15?
75 minus 15, yes. So what's that?
60.
60. And what percentage is that of 75? How do we figure that out? We say 100% minus the 20 right here, and we get 80%, right? So if 15 is 20% of 75, then 60 must be 80% of 75. And again, just to make sure everybody saw how we got that number, 75 minus 16, I'm sorry, minus 15, 75 minus 15 equals the 60, that's that number. And 100% minus 20% equals 80%, and that's that number, right?
How'd you get the 75 in the first place?
The 75 was the number that we determined from this formula, right? This was the question we were initially asked, and so we converted that question there to, using this formula that we know here, to this, 20 over 100 times some whole number equals the part, which they told us was 15. So we solved this equation here to get our 75.
The only way I could have seen it is by adding the 20 and the 15 and then subtracting it by 100. That's what I thought you did to get 75.
No, I mean, we always start with our formula here. So we've got some percentage times some whole equals the part, right? So that's what you guys have to, you got to burn that in your head, right? That's true for fractions. A fraction of some whole equals a part. A decimal of a whole equals a part, and same way a percentage of a whole equals a part, right? So you got to be able to write this formula down first before you do any of this stuff here, right? You got to be able to write this formula down, solve for the one that's unknown, and then you can write down the diagram. All right, let's try it in a way that's asked a little differently, and see if you can do it. What percent of 140 is 98? What percent of 140 is 98? All right, remember our formula is this: some percentage divided by 100 times a whole equals the part. And I'm gonna write that like this. Well, percent of the whole is the part. Right? That's why I'm saying percent times whole equals the part. Is represents the equal, of represents the times. Okay? So if that's true, what are we plugging in our formula from this question here?
The percentage over 100.
Yep, percent over 100, so that stays the same because we don't know what the percentage is.
The whole is 140.
The whole is 140 because that's tied to the of part, right? So times 140
And then equals 90.
equals 98 because the 98 is tied to the is. Everybody see that? See how clear the language is once you recognize that the is represents the equal and the of represents the times. So now this is the formula that we're trying to figure out. And the percent symbol in this one is functioning as our variable. All right? So how am I gonna simplify this guy? My basic algebraic equation, I'm gonna take percent, and I'm gonna write that as, we'll do it as WP. What percent? What percent over 100 times 140 equals 98? How do I solve for WP?
Would you just reverse all your past steps, or?
The steps are kind of the same. I want you guys to see this. What is WP over 100 times 140? Is there another way I could rewrite that? Do you guys see that since this is just a fraction multiplied by this, how do we multiply a fraction times a number? What is 2/3 times 4?
The denominator is typically 1, so you just put a 1 under it and multiply.
So we think of this as 1, right? And so we just multiply the top and we come up with 8/3, right? That's the same thing we've got going on here. There's an understood 1 there, right? So we could rewrite this guy as 140 over 100 times our top part there, times our WP, equals 98. Do you guys see how I was able to do that? Now do you see that this looks exactly like the equation that we had before, where we have to multiply by the reciprocal to simplify it? So we're going to multiply by our reciprocal. Our reciprocal in this case is the 100 over 140. Right? Again, these cancel out. And so we say the what percent is going to be 98 times 100 over 140. And the math's going to be a little bit harder on that one. Somebody's going to have to punch that in for me. It's like whatever 98 divided by 14 is. I'm sorry, 980 divided by 14. Or 9800 divided by 140, however you want to think about it. What do you guys get?
I got 70.
70. So our percentage is 70%. All right? So this is what the problem was asking for. You're going to get most of your credit for the problem if you can give me the correct answer there. But then if it asks you for the diagram, I want you to be able to draw the diagram as well. So let's see if we can do the diagram for these guys. The before part, when we were at 100%, is whatever is connected with our of in the original question. So of what? What goes with the of part?
98.
Is that what it says up here? Is the of in front of the 98?
Oh, 140.
140, right? Of 140. So the 100% part is of 140. And then 70% of that, I'm going to make this part bigger and say that 98 is 70%. What's going to go down here? Something that is 30%, because 100 minus 70 is 30%. What's the number that goes there?
42.
42, because 140 minus 98 equals 42. So this is our after part. The way they did theirs is they put the 30% up top. They put the smaller part up top, which is fine. Either way would be correct. That's the way they did it in the book. Does that make sense? Yes.
Okay, then you're probably gonna absolutely love this question because you get it all the time. What is the point of having, like, just curious, why are you diagramming it afterwards?
Afterwards?
Yes, like after you're completely done with the problem?
Yeah. Really the point in the diagram is to make sure that you can calculate this part. Okay? It's just making sure that you understand if 98 is this, if 98 is 70, then you know just by just simple subtraction, you can figure out what 30% is. Because that's the other part of 100%, right? We found 70%, we can figure out what 30% is. Because some of the way that these problems are phrased, they're really asking us for this number down here, but because of the information they gave us at the beginning, it might be easier to find this first, and then just do subtraction and figure out the 30% part, okay? All right, so these problems were all of these problems so far that we've done have been problems where the percentage is less than 100, all right? Sometimes we don't want to find a percentage that's less than 100 though. Sometimes we want to find a percentage that's actually bigger, like something increases. So let's see how we would do that one. And I'll give you an example. Like, you're buying something in the store. If you're buying something for $2, is that how much the store paid for that product?
No.
If it is, they're not ever going to make any money, right? There's always a markup on the products that we have in the store. So there's some percentage increase. So like, for example, maybe they mark up, whatever they buy it for, they mark it up 50% from what they bought it for, all right? So let's see if we can do a problem that's like that, where the percentage is greater. So let's just say, let's do a simple one like that. Let's say that we have, we want to know what the cost of an item was to start with. And we'll say that they're selling it for $20, all right? So the store's selling it to me for $20. I know that they're marking up everything by 50%. What was the price that the store paid for the product? All right, so let's see if we can figure that out. And the question that we would ask with something like that is, it's not 50%, it's they paid some initial amount and then they added 50% to that. You guys see that? So there was 100% that they paid for the product, but then they marked it up 50%. So they marked it up another 50%. So the final price that I'm paying is 150% of the original price of what the store paid. Okay? So $20 is 150% of what number? That's really the math problem that we need to do in order to figure out what the store paid for the product. Okay? Now, our initial equation that we're going to write down is exactly the same equation that we've always been writing down with these percent problems. What would that equation be? Who could write the equation down for me? Or tell me what to write down?
150 over 100.
Over 100. That's what we always do with our percentage. Okay?
Times what number?
What number?
Equals $20.
Equals 20. Excellent. Does everybody see that? The 20 was connected with the is, and so she put it over here by the equals. The what number was connected with the of, so she put it right there. Right? This is our of. This is our is. Okay? If you'll pay attention to those words in the problem, you'll always know which number to put where. So this is the simple problem that we have to do. We're going to do what we've always done when we get rid of this fraction here. We're going to multiply through by the reciprocal, right? For these percentage problems, you're always going to have to do that. And so these cancel out, and we get that what number is equal to 20 times 100 divided by 150. So that's going to be 200 divided by 15. And what is that? Can I have that? Decimal?
13.3.
13.3? So 13.3 is what they actually paid. They paid $13.30 for the product, and then they charged me $24 when they marked it up 50%. All right? Well, I'm going to leave the dollar part off because I didn't put dollars in any of this stuff in the initial question. So 13.3. Now, what about your diagram? The diagram is going to look a little different whenever you've got a percentage that's greater than 100%. Okay? The first part of your diagram is going to look the same. You're going to have the before, which is the 100% part. But then your after is going to look like that. Because there was an increase. Because it got bigger. So our circle over here grew compared to this one. So the before 100%, what was the number that we started with? What was the 100% number?
150%?
No.
No, 50%. Oh my God.
This is our number.
20?
Our number is at 20. We got our choices are this: either 13.3 or the 20 right here? Oh, I did put dollars in there, didn't I? I didn't remember that. So we'll put a dollar sign here too.
So is it 13?
It's 13.3 that we started with, right? That was the amount that the company spent on the product. And then afterwards was the price that they sold to us. So after, they increased it to $20. And what we found out is that $20 is 150%. So that's the bigger percentage there. So this one here, we don't break it up into we're not breaking up the 100% because the number, like we do on our other problem, because the number that we end up with is bigger than the 100%. Okay? So that's how you diagram those. Does that make sense? Can you think through that? It helps me, it always helps me with these math problems if it's kind of more complicated what they give me. It helps me to think of some simple problem like this, like purchasing something in a store, knowing that they marked it up, right? Those kind of things kind of help me remember, they marked it up 50%, but that means that the price I'm paying is 150% of the price that they paid. So sometimes just thinking about a simpler scenario than what they're presenting to you in the problem may help you do the problem correctly. All right, let's do one that's straight out of the book here. Any questions about this?
Can you use the restroom?
Yep. Any questions about the problem? Let's do another one. I'm going to leave this here because we're dealing with percentages that are bigger than 100% for all of these. So let's listen to how this question is posed. If 75 is increased by 150%, what is the result? All right, who can give me the equation that we're starting with?
150 over 100. I know that's how you started, but I'm not sure.
150 over 100. That's not quite right, but we're going to come back to that. All right. So 150 over 100, he says. What is this multiplied by? Is it the is or the of that goes after our multiplied by? Of. So we don't actually have of in here. This one can be a little tricky because we've got two is's. We're going to have to think about this one. 75 is increased by 150%. What is the result?
So would you multiply it by 75?
You would, yeah. We're doing, the 75 is what's increased, right? This is increased to give us what is the result, to give us some result. So this is what we're trying to find here. This is what number would go there for this problem. Okay? So that's the basic construction of the formula. The mistake that you made, Will, is the most common mistake that people make with this problem. All right? And this is what we need to think about.
Bigger?
Huh?
Would you put on the bottom 150 over 100?
No, what the problem is 75 in this case is 100%. All right? That was, like when we do this here, this is going to be of 75. All right? That's the number we're starting with. That's our 100%. We're increasing that number by 150%. So if we were 100% to start with, and we're increasing it by another 150%, yep.
So would you do 75 over 100?
No, you got to make this number 250. Our percentage is 250% because we start with 100% and we increase that by 150. So 100 plus 150 is 250. Does everybody see that?
Yeah.
And it's just weird because of the wording there, but that's just something you have to pay attention to, how it's phrased. Remember when I gave you guys my problem a moment ago, I told you that there's a price that the store paid for it, and then they increased that price by 50%, right? To get the value that we did, but we didn't do 50 over 100, did we? We did 150 over 100 because they increased the price by 50%. And so same thing here. Here it's increased by 150%, so we have to add that 150 to the 100 to get 250 over 100. Does that make sense to everybody? So now this is actually the easiest one that we've done so far because we don't have to multiply by the reciprocal to get rid of the fraction because all of our numbers are already over here and our unknowns on one side by itself. So we just have to punch in our calculator 250 times 75 divided by 100. What'd you get?
187.5.
187.5 equals our what number? Okay? So that's the answer to the question. And then when we draw the diagram, we have the of 75 here, and after, we say 187.5 is 250% of 75. Questions? Yes?
Just restroom.
Yeah. Yes, Ada.
I am so confused as to how you got 250. I know you just explained it,
That's okay.
but I'm
That's
trying
good.
to connect it.
No, that's good. Again, think about it this way. Go back to the problem that we had before. All right? We know the company paid some price for the product. They increased that price 50%, and then we pay the final price. So let me ask you this question. If they're increasing the price by 50%, am I expecting the price that I paid to be more or less than what they paid?
More than what
More, because they increased it by 50%. Okay? So really the problem we did a minute ago was the same thing. If they gave us the starting number instead of the ending number, which is what I gave you before. So we're going to do what we did before. If $13.30, right, is increased by 50%, what is the result? Okay? That's me asking the last question a little different way. What are we going to get for our result? We know from the last problem we're going to get $20, right? So let's say I don't add 100 to my 50. So this would be what that problem would look like. It would look like 50 times 100, 50 over 100, right? If I just take the 50% times 1330 equals what number? All right. If I do that math right here, what's 50 over 100? That's just 0.5, right? That's a half. If I do 50 over 100, I'm going to get a number that's smaller. I'm taking half of that. Do you see that? And so that's why on our last problem, we said it was increased by 50. This is the starting amount, so this amount represents 100%. Okay? I'm increasing it by 50, so 100% plus another 50% gives me the 150%. This is what the problem has to be. All right? That's the same thing we had to do here because it was increased by 50. So when you see this word increased, you know you're going to have to take 100% and add this new percentage to it.
So you always take 100% and add it to it if you have this problem.
If it says increased by, all right,
Okay,
you
so-
always take the 100% and then you add the new percent to it,
So this goes for like every single problem like this one.
where it says is increased by, okay? So this is the key. You're looking for that language, it's increased by. Here, 1330 was increased by 50%, so instead of 50%, I have to add 100 to it to give me 150%, okay? Good question. Now, I get it. These are the hardest problems. These are the problems that I knew would take the longest to explain. How are you going to get good at these problems? Working them over and over and over again. If you do enough of these problems, I promise you, eventually you're going to go, I see the pattern, I understand it. If I get this on a test or a quiz, no problem, right? So I'm going to assign certain homework, right? It gives you the opportunity to practice this. All of the practice section asks you about this. What I always do is I assign the odd numbers in the problem set, right? But if you look in your book on page 190 and 191, actually specifically 191, since I'm going to assign the even numbers of the problem set, that means you're going to have to work problem number 5. And problem number 5 is one of these problems. Problem 5 says 20% of what number is 18? And so they tell you to work that out and to draw the diagram. All right? But number 6 is also one of these types of problems. Number 6 says what number is 140% of 70? Work that problem and draw the diagram. I'm not assigning number 6. But if you're not grasping this yet, you need to do number 6, right? You've got to look for those problems that are extra problems to give you practice. Now, when I'm looking through the homework, how am I going to know which one goes with this chapter? Well, it's got the little number in parentheses underneath it, right? So if you're like, I'm struggling with lesson 47, I'm going to do every problem in here that has lesson 47 listed. And you know what? I'm going to do that when I do the lesson 48 homework as well. I'm going to do every problem, whether it's odd or not. In lesson 48, problems 5 and 6 are both from 47. So if I'm struggling with these concepts, I'm going to do both 5 and 6 until I get it down. Okay? I probably have told you guys this. My calculus professor was exactly right. You guys can all do this stuff. It's just some of you are going to have to do more problems than the next guy. So if you want to get good at it and understand it, you're going to have to do a little bit extra work, but it's going to pay off. It's going to pay off in a big way. And these problems here, you're going to see problems like this on standardized tests. This is going to affect your ACT and SAT score, right? These problems aren't going away, so you need to know how to do this. And these to me are really easy problems. You know, one of the struggles that people always have with math is they're like, when am I ever going to use this, right? I get that question all the time, especially in the higher level math classes. But this stuff, I just did a normal, I'm shopping in a store and I'm having to pay this amount kind of stuff. This is like discounts when you're spending your money and that kind of stuff. This is what you use to figure out those discounts or figure out how much more you're having to pay, right? So this is real world stuff. This is definitely things that you will use in the future. Or you'll get taken advantage of because you don't know how to use it, right? So this is good stuff to know. This is important. All right. Let's do lesson 48 and we'll be done for today. And lesson 48 is discussing the topic of polynomials. I don't think this line was on the board before the break. It looks like it'll kind of come off. I'm going to figure that out. Will it come off with this? That dry erase? Let's see. It does. All right. Sorry, give me a minute. Help the next teacher out. Who's just this classroom? Well, somewhat. It's a little better. By the way, did anybody lose an earring? There's an earring sitting on the tray up here. It's a gold loop. Everybody's good? I was here when I got to class today, so. All right, there. No? Maybe it's a nose ring. Anybody wear nose rings that day?
You scared me. I thought it was mine at first.
That was pretty big. All right. For a nose ring. Not too bad for a ring. All right. Let's talk about polynomials. So let me write these expressions down that they have in the book. This, these are all what we call polynomials. All right? And with polynomials, the way that we know polynomials is that they are of this form here. They have a term. It's a series of terms that look like that. It can be one term all by itself, or it can be the terms that look like that added together, where A is a real number So that's a real number, and that n is a whole number. So let me ask you, how can by this definition here, if it's of this form here, how can this be a polynomial?
Because it contains a whole number?
It has a, well, the 4 here, the whole number is the exponent on our x term, all right? Is 4 an exponent? It's not in this problem, right? That's not the exponent on a variable. So in this particular polynomial expression, the 4 is equal to the a right there, all right? But is it true that 4, do you guys agree that 4x to the 0 is the same as 4 all by itself? What is x to the 0?
1.
Just 1, right? And 1 times 4 is 4, right? So these two expressions here are equivalent to one another, right? And so I can write 4 in this form by writing it like that. Does that make sense? So 4 corresponds to a, and my 0 here corresponds to n. All right, so that's why this is a polynomial. It actually does match that form there, right? This one's very easy to see. The a in this one is -4, right? And the n in this one is the 2. Now, like I said, this could be just one term, or it can be multiple terms added together, and that's what we have right here. We have one term where a is 7 and n is 2, and we have a second term added to it where, again, this is the same as 2 times x to the 0, right? Where a is 2 in the second term and n is 0 in that third term. This one's a little wacky and a little harder to see, so and really it's beyond the scope of what we want to talk about right now. So, but I do want to just say that we can think of x squared over y as just x squared times y as just a single variable. We could say that was equal to like a single variable, something like p, and so we could think of this as 4p to the 1, where p equals x squared times y. Is really what that term is there, so that still qualifies as a polynomial. But this, most of the time, something in a form like this is what we think of when we think of a polynomial. All right? It's a series of terms that contain the same variable, and the variable will be to different powers in the problem. All right? And this one's a really easy one to see what the degree of the polynomial is. The degree of this polynomial, the degree is always the highest power on the variable in the polynomial. So if that's the definition of the degree, what's the degree of this polynomial here? What we say is the degree of that. It's the highest power, the highest exponent on the variable.
3.
3, right? So this is a third degree polynomial. All right? What's this one?
2.
That's a second degree polynomial, right? This is also a second degree polynomial. And this one here is a 0 degree polynomial. All right? So it's always whatever the highest power is on the exponent. That's how we determine the degree of a polynomial.
You said that it was 0 degree for that one?
0, yeah, because that's the highest power, right? So you're going to have some problems where they ask you about that. Well, actually they're not. I don't see where they specifically ask you what the degree is, but I do want to make sure that you understand that term. Now, when we add polynomials together, so let's say we have something like this, and this is what your homework's going to be about. Let's say we have 2 polynomials that we're adding together. All right, here's our first polynomial. What degree is this polynomial?
3.
third degree polynomial, right? We're going to add to that another polynomial that happens to also be a third degree polynomial. Doesn't have to be. This one doesn't have to be the same, but in this case it is. So when we're adding this together, we can only add together terms where the individual terms have the same degree. Or another way to think about it is that we can only add together terms where the variable portion of the term is exactly the same, right? So is there anything that I can add, if that's true, is there anything from this polynomial here that I can add to this x cubed term here? If the variable portion has to be exactly the same in order for me to combine the terms, do either of these terms have the exact same variable portion as this guy? What's the variable portion of this? Just the variable part. What do I mean when I say variable? Everybody understand that terminology? What's my variable in this whole problem here? What's the variable?
X.
X, right? Our variable is x. So the variable part has to be exactly the same. Now this variable, x, has a 3. It's to the power of 3. Do I have a term over here to this to the power of 3? I do, right? So those can be combined together. And then this one right here has no variable on it, or we can think of it as having an x to the 0 power, right? Just like this one has no variable listed for it. So those terms I can combine together. I can combine these two terms, and I can combine these two terms. Those are the only terms that I can add together in this problem. Those are the terms that we would consider to be like terms. All right? So I'm going to put them right next to one another. X cubed plus 2x cubed. There's nothing that goes with this 3x squared, so I'm just going to put it here in the middle by itself. And then I'm going to put these two terms beside one another, plus 2 plus 4. All right? How do I combine these like terms here? What is x cubed plus 2x cubed? We've actually talked about combining like terms before, so this should be sort of old news to you. But I want to make sure you guys get it. How do you combine two like terms together?
You just add them.
I add what portion of them?
The exponents.
Not the exponents. The exponents are these numbers here. What I'm adding are the coefficients, which are the numbers in front. That's okay. What's the number in front of this?
It's a 1.
It's an understood 1, right? So I'm adding together 1 and 2. So I get 3x cubed when I combine those together. Right? Does everybody see that? See how I did that? 3x cubed. There's nothing that combines with this, so we just write this down again, plus 3x squared. And then when we combine 2 and 4 together, we get 6. So this would be our answer for this problem here.
Aren't you usually supposed to add the smaller numbers, like the ones on top of the variable?
That's when you multiply it, right? If we'd had x cubed times 2x cubed, yes, we would have actually taken the understood 1 here. 1 times 2 would give us 2, and we would have added the 3 and the 3 here, and we'd have gotten x to the 6th, right? Yes?
Wouldn't you add those like terms at the bottom?
Which like terms?
The final result,
Are there any like terms in here?
3x and 3x.
This is 3x cubed, and this is 3x squared.
Oh.
So they're not like terms because the powers are different on the x. Does that make sense? The powers have to be exactly, the variable and the power on that variable have to be the same in order for them to be considered to be like terms. Okay? So that's as far as we can go with this problem. And the way that we always write this, the kind of the rule for writing your polynomials is you write them in order of descending powers. All right? So that's why I put x cubed first, and then I put x squared next. Had there been just an x term, I would have put that next, and then I put the number all by itself last. Okay? That's the convention for writing polynomials. So you guys are going to get to the point that we need to get to is that you see a problem like this, and you just immediately go, oh, the x cubed term, this is an x cubed term and this is an x cubed term. I can combine those together. This is a term with no variable. This is a term with no variable. I can combine those together. All right, so you just immediately see the terms that you can combine. You recognize the like terms. All right, so we got to get good at that. So let's try another problem. And this time we have these polynomials. We have 3x to the fourth minus 2x squared plus 3x, plus 3. That's our first polynomial. We're going to subtract from that another polynomial, which is x to the fourth minus 2x cubed plus x squared. Now here's the way that here's what I want you to do with this. The first thing that I want us to do is to get rid of these parentheses. It wasn't as important in the last one because everything was added together. It's crucial in this one because we're subtracting, okay? And so if we're going to get rid of the parentheses, this one there's nothing in front of this, so I don't have to do anything. I could just rewrite this guy here. All right? But for this one, if I want to get rid of the parentheses, I need to understand that this right here is like I have -1 times all of the terms that are in here. All right? Because there's a negative sign in front of this, it's like I've got a -1 that I'm distributing through to all of these terms. All right? So if I'm getting rid of the parentheses, what is my first term that I'm writing down? I'm thinking of that as -1 times x to the fourth. What's -1 times x to the fourth? I know some of you know it. What's -1 times x to the fourth?
-1 x4.
Yeah, negative, and we don't normally write the 1, so we would just say -x to the fourth, right? It wasn't a trick question. But some of you are still struggling with these things, so I'm asking sometimes super simple questions to make sure everybody gets it, all right? So we're distributing through, which means we have to multiply this -1 times each term, right? So now we've multiplied the -1 times the first term. What's -1 times the second term? -1 times -2x cubed is what?
-2x.
A negative times a negative gives us a
Positive.
positive, right? So it's positive 2x cubed. Right? And then here we have a negative times a positive, so we're going to get a negative x squared. Does everybody see that? Or rather, should I say, does anybody not see that? Now I can combine my like terms. This is a like term with this term. So what's 3x to the fourth minus x to the fourth?
Would that just be 2x4?
2x to the fourth, right? Because since we're doing subtraction, addition/subtraction, you only add or subtract the coefficients in the front, right? And leave the variables the same. So 2x to the fourth. Does everybody see how I got that? 3 minus 1. They understood 1 in the front here. Now we're going to move on to our next term. Now we're going in descending order. So if we did x to the fourth, we want to look at the x to the third next. How many x to the third terms do I have? Do I have any? Are there any x cubed terms? Is it not an x cubed?
Oh, I thought you meant like more light terms.
No, yeah. Do I have any at all? I have one. I only have one, right? So I'm just going to take this guy and I'm going to write it down here. Now I'm moving on to the x squared terms. Do I have x squared terms? I have 2 of those, right? So now I'm combining together this and this. -2x squared minus x squared is going to give me what?
One x squared.
No. What's
Wait, what?
what's -2 minus 1, right? That's our coefficients in the front. -2 minus 1. What is that?
-3. 3.
Negative 3. So it's negative 3x squared. Right? You guys see that? And so I've got one other term left that I have to take into account, this plus 3. So I bring it down. So this would be my final answer for that guy. All like terms are combined. I've written my powers in descending order. And I didn't leave anything out. I brought everything down that was up here. Okay? Everybody see that? All right. Last one, I'm going to do it very, very fast. Because sometimes maybe I'm talking through it too slow, and that's why you guys don't get it. So if I do it so fast that you have to like really pay attention, maybe you'll get it. So 3x cubed plus 2x squared minus x plus 4. They've already very kindly written it in descending order for us. If they didn't, we should write it in descending order of powers, just so we can keep everything straight. All right? I want to get rid of my parentheses first. So I'm just going to drop the parentheses on the first part, 3x cubed plus 2x squared minus x plus 4. I want to get rid of my parentheses on this one. And what I notice on the second one is that I've got a minus sign in the front here. If this was a plus sign in the front, I could just remove the parentheses, because I would be basically multiplying everything by a positive 1. But I need to multiply everything by a negative 1. So I'm going to get negative x squared, positive 7x, positive 5. And what I did is I just distributed through this negative 1 that's represented right there by the minus sign in front of my parentheses. Right? So that forced me to flip the sign on each of these terms here. All right, now I'm combining like terms. Do I have any other x cubed terms?
No.
Nope, so I'm just going to bring that down. Do I have any other x squared terms?
Yes.
Multiple? I do. I have this one and this one. 2 minus 1 is 1. So 1x squared, and I'm just going to write that as x squared, because the 1's understood. I have 2x terms. I have a negative 1x here, and I have a positive 7x there. So negative 1 plus 7 is 6, positive 6, so positive 6x for that. And then finally, 4 plus 5 is going to give me a plus 9. So that's my final answer for that. All right. So again, if you're struggling with this, I'm going to assign just the odd problems, but do some extras, right, until you get this down. All right, you guys have a wonderful day. Welcome back from the break, and Lord willing, I'll see you next time.